Okay, let's look at unpack alignment. GL pixel store I. I know I looked at this earlier. Okay, and then we're gonna go unpack alignment. Okay, unpack alignment, sorry. Unpack alignment specifies the alignment requirement for the start of each pixel row in memory. Yeah, that would change things, right? 1 byte alignment, 2 rows aligned to even number of bytes forward alignment. Yeah, but then again, I mean, 1, 2, and 4, right? These are even values. And you could have something that's a non-even value for like the number of components per in your pixels, right? You could do like you could have like RGB, right, where there's no alpha, and then it's 3 components per pixel. And then if we were to assume that this alignment here was the number of components, and we have just RGB and there's 3 components, well, 3 is invalid alignment value. So okay, so it's only 4 by coincidence, and we don't really need this. And with it being here, you'd be like, why is this unused thing here? Oh, maybe here's a magic number. Maybe they meant to use it there. So I'm going to say, let's just not do that. Let's not open ourselves up for that mistake there. And we don't really need a scope here. Let's remove some of this indentation. I mean, I kind of see why I did that, but let's not. Okay, I'm getting tired. It's like 5:34 a.m. So let's try to wrap this up. Or not. Well, I'm not going to get it yet, but okay. So for var I equals 0, I is less than 2, and I plus plus, right, going through both elements. And here's our data array. Let's highlight that for a second, because we need to use I here. Data array I. Okay, so everywhere that we're using a variable, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Everywhere we're using a variable, we have the I. Okay, so there. So now we're just gonna loop over this twice and call it on this data here. And the reason I'm doing it that way instead of like giving it to a function is because this kind of preserves the linear order of where stuff is, and it's that just trying to keep everything as linear as possible makes code a little bit easier to read. So I'd like to preserve that linear order for my own reading pleasure. Is there anything else? So obviously we need to the pixel array here, it would be nice if we could fill it with some type of pattern, and we would really want to do that here. So we could actually do like we could do pixdex. Yeah, var pixdex equals 0, and then pixdex is less than or equal to, and then pixdex plus plus. It's a little wordy. And then what we do is out here we have var pix max equals, and then the data array. So this data array up here, and we just multiply the pix width times the height times 4 of, well, it depends on how we do this. We could just go over each pixel. Well, yeah, because this is pixels, so pixel width times pixel height to get all of the pixels, but we said pixel max, not pixel len, so -1. So max for maximum index, and we could just go through the data array. So the data array I, and dot pixel array, and then the pixel dex plus 0 equals, and then when you're setting a pixel, right, we'll just offset by 1 byte. So the first byte is going to be R, then the second is G, the third is B, and the fourth is alpha. And usually I do something really simple, you know, like, right, we could do the pixel dex modulus 255. And if we want like different colors showing up here, we could keep it really simple, and we could just modulate by different values, right? So that the frequency of the wrapping is shorter, and then also the colors will be darker, right? Because they don't get as high. But that is a quick and dirty way to get some type of pattern in there. So when we're sampling in the shader, we can verify that there's, you know, some type of data there, you know, because if this is just initialized to black or white or something, we're not going to get the feedback we need when we run the shader. So this would be very helpful just to have this, so we kind of like populate with you know, populate textures with bogus pattern for feedback. Populate textures with bogus pattern for feedback. That's basically what we're doing. And then all this stuff. Okay, so that looks good. And if we give that a run, I probably made a syntax error somewhere, but we got most of that figured out. That was a lot of explaining and stuff for not much code, but hopefully, you know, the thought process there was useful. And I'll think I'll continue this at a later time because I'm just kind of tired. All right, see ya.